The CPU, or the Central Processing Unit, is the brain of the computer. It is a very intelligent creation made by man that computes and processes information based on its respective instruction set. They run the processes that you would like for the computer to do, from the keys that are being pressed on the keyboard to the editing software that we run on the monitor. It is the main processor that analyzes the simplest to the most complex data to be executed. The Moore's law dictates how CPU can be built, which provides inventors ideas that it is possible to double the number of transistors per area about every 2 years. And because of this discovery, the CPU that we know 40 years ago that is bulkier and gigantic can be fitted into this single chip called as a microprocessor, which can also perform all the necessary functions that the bulkier, older processor can do. Because of its size, the signals travel faster, thus providing a faster computing power than older versions. It did not only improve the functionality of a CPU, but also lessen the price range. Technically, the goal of a CPU architecture is that to make a design that is easier to understand and to process. Thus, von Neumann introduced his own take on this matter, which is now what we call as the von Neumann architecture. His idea is to have a main memory, which stores all the necessary instructions, a separate central processor, which executes the instructions from the main memory, and the input-output interfaces, which serves as a medium to send and receive data. Neumann also emphasized the 4 important steps in the instruction cycle: fetching the instructions from the main memory, decoding those instructions, executing them, and storing the data back to the main memory. This has been the basic principle that the modern architecture uses today. Intel 4004 paved the way in designing microprocessors by having 2,300 transistors with a clock speed of 740 kHz. It is the first programmable processor that combined the capability of the ENIAC into one single chip. Yet it was a bigger breakthrough when the Intel 8086 was released in 1978. It is a 16-bit processor with an x86 instruction set architecture and has been the foundation of modern CPU designs until now. Because of these breakthroughs, so much has changed in the semiconductor industry. The recent dies that we know today have billions and billions of transistors in one single chip, and smaller in size than older dies with having thousands of transistors. What's amazing is that older dies are made by a team of engineers, but now, a single engineer deals with 100 chips every day, all thanks to abstraction layers which serves as a guiding light for design engineers. In building a microarchitecture, the ISA plays an important role as it dictates how instructions are being processed. The design on the microarchitecture depends upon the type of instruction set being implemented on the processor. A collective term used to describe the fetch, decode, execute, and store cycle is called a pipeline. The goal of using a pipeline as a process is to have better work efficiency. To have several pipeline stages in parallel, the faster each stage can be. Since pipelines work synchronously on the clock, the computing speed per pipeline depends upon its clock speed. Modern CPUs have 5 GHz, which means it can compute 5 billion instructions per second. Branching is a fork row in an instruction where we have to decide whether to continue the same path or go the other way. Branches are common in codes, and the decisions that are being made reflect the speed of a processor. It could make the microprocessor slow when canceling a wrong path. Because of this, engineers invested on branch prediction and speculative execution, which are both helpful in having fetch jump to execute smoothly without noticeable delay. The front end of the microprocessor is composed of the fetch and decode stage. Branch predictions are located here. Modern predictions are so advanced that they are able to relearn 1,000 of past predictions to provide accurate guesses in the present and the future. The caches are little memory storages with faster clock speed to optimize the process of routing back to the main memory. The main goal of the front end is to have enough and ready instructions for the back end to execute to avoid idle time. Multiple and fused UOPs are also helpful in simplifying the data that is coming out from decoders, making it easy to execute and store in memory. The decoded UOPs are then being fed to the back end of the CPU, having a variety of operations to be executed. The scheduler then analyzes these instructions to see if there is a dependency of the instructions going on. Dependent instructions will have to wait, while other instructions without any dependency will go straight to the superscalar vector ALUs by executing them out of order. The dependency is still considered until the retirement to get correct results. Superscalar and out-of-order execution is a huge help in the backend to process thousands of instructions and get expected results quickly. This is a summary of a CPU design and architecture.